Hey everyone, so am I real? This is the question that I'm going to pose to all of you right now listening to this channel, listening to this session.
It's hard to breathe, but that's alright. Hush.
So hi, welcome to my channel. This is Dr. Lowell Sala once again of NYC Emerging Healthcare Technology and MedTech Solutions.io, your go-to place if you want to learn more about digital health, if you want to learn more about emerging technologies such as blockchain, machine learning, artificial intelligence, data science, and even as simple as web development. So this next topic, I'm so excited because I'm going to show you, I'm going to bring you now to a world where I'm going to blur reality, where I'm going to blur what is real and what is synthetic, or what is fake or not real. So the question that I'm going to pose right now is, am I real? Is the person that you are seeing right in front of you, is it real, or is it just an image generated by a machine learning model or machine learning framework? So this is actually an introduction to a topic which I love, a topic in machine learning known as GANS, known as Generative Adversarial Networks. So before I begin, of course, I'm going to show you a series of images, 5 sets of images to be particular. And I'm going to ask you now to get a piece of paper, and in that piece of paper, please make sure to write which of the images that you are seeing right in front of you is real. And if you wanna, of course, feel free to feel free to pause this video if you want a more clearer visualization of the images that I'm going to show you. So the question I'm going to ask right now is, who is real again? Is the image that you see in front of you real? Is image A, for example, real as opposed to image B? Is image B real? So these are the 2 images that right now I'm going to ask you to write in a piece of paper that you think the image that you are seeing in front of you is real. And again, this is a topic on generative adversarial networks, so meaning I have to be able to also assess if you are even able to see if the image that you see right now is real. So I'm going to give you a few more seconds. I hope that is okay, because we are going on a rush right now. So yeah, do you think it's image A or is it image B? Right? So the second set of image that I'm going to show you again is this one. Is the person that you see in front of you real, or is it just a figment of your imagination? Now, is it just a figment, or is this just a creation of a machine learning model that is so advanced that you are able to actually trick you into believing that the image that you're seeing is real? Is it image A or is it image B? Note that this actually, you can, if you look at a lot of profiles right now in Facebook and LinkedIn and even Twitter and even YouTube, you have to be able to identify if the person that you are talking to, or the person that you are engaging with, is actually a real person. And this is important because right now, all these deep fakes are happening, and all this actually goes back to the concept of generative adversarial network. Okay, so I'm going to give you a few more seconds. I hope that's okay with you. All right, and then the next set of images that I'm going to show you I'm showing you right now, is this one. So if you think that the image that you see in front of you, or image A, is real, then write on that piece of paper that I have asked you to bring, if you think that the image right now in front of you, A, is real, or if you think that the image B, that the one that you're seeing in front of you, is real. It's fascinating, right? Once you think about it, that you can actually now manufacture all this, images, thinking that, that who you are talking to right now. For example, in Facebook, if, for example, there's a hiring or an HR process, and then you thought that, you submitted for example, your CV, your resume, thinking that the person that you are actually talking to is a real, like HR person, and then turns out later you find out that the person is not actually a person. So is this a human being that you are seeing right now? The image that you're seeing right now, is this really an image of a human being, or is this just a creation of a complex machine learning framework? Okay, So this is, I think, the fourth set of images. So if you think that the A is a real breathing human being, or a human being or a child, then write on that piece of paper A. If you think that the real person here is B, then again write on that piece of paper that the person that you're seeing right in front of you is real. And in fact, there are so many applications of this, especially if you look at it in the context of imaging for healthcare purposes. For example, even with a simple image of a heart, for example, you can already create all this nice images with a blurry image of a heart, for example. And then this is the last of the images that set of images that I'm going to show you. So do you think, for example, that the image right in front of you, image A, is a real breathing person, quote unquote? Or is it B? Is B a real breathing human person, quote unquote? So this is one of the fascinating aspects of the topic that I'm going to tell you or talk to you about. And again, make sure to wait, make sure to watch this entire video, because at the very end, I'm going to show you now who among these images is real and who among these images is just faking it. So these images, some of the images that I've shown you are just fake images. So meaning these are images, these are not real people. So make sure to wait, or not to wait. Make sure to listen to the entire topic, because I'm going to talk about how this generative adversarial networks came into existence and what are its implications in healthcare specifically. And yeah, before anything else, if you haven't subscribed, please make sure to click that subscribe button and ring that notification bell so that you will be able to hear and see every time I upload a new video, new contents, and all these things. Please also make sure to like if there's any topic that you want to like, and make some comments down below. So with that, I'm going to go now to the next chapter, as I will show you now how this generative adversarial networks came into existence and what are the implications of this networks in healthcare.
Tell me pretty lies, look me in the face, tell me that you love me, even if it's fake.
Okay, so in 2014, this is actually quite a fascinating story. It was in 2014 when Ian Goodfellow and his colleagues at the University of Montreal published a paper introducing the world to GANS. GANS actually is short for generative adversarial networks, and in its simplest terms, it is a type of machine learning model or a machine learning framework where you're giving a set of data or a training set, and then with this training set, the machine is actually able to generate new data or new images. So you can actually what you do here is that you can train the machine with this images or photographs, and then basing on these images, you're able to create an image that is aesthetically or superficially similar to that of the real image. So based on two components, which is your generator and your discriminator. So these two aspects later on are very important once we go to discussing generative adversarial networks. So with this innovative combination of computational graphs and game theory, they showed that given enough modeling power, two models fighting against each other would be able to co-train. To co-train through plain old backpropagation. So backpropagation here actually is applied in both networks so that the generator produces better images, while the discriminator becomes more skilled at flagging the synthetic messages, the synthetic images. So if you can see, there's two conflicting parties or components here. One is the generator, which just generates everything, and one is the discriminator, which tries to correct everything that the generator creates. So again, when we talk of GANS is just a simple machine learning framework wherein you have two neural networks in contest with each other in a game. So the generator initially generates images, and if you look at it, initially what the generator creates are random images, so it may look weird images, but with the discriminator coming in, the discriminator guesses if the images are fake or real. And with this game, ongoing, eventually the generator will come up with an image that is much similar even to that of to the real image. And you're actually, what you're doing here is you're actually training the discriminator to show the discriminator that this is, for example, an image of a human being. And then with that game happening, the generator will be able to create now a much better image of a human being, or an image based on what the discriminator is actually telling the generator. So given a training set, this technique learns to generate new data with the same statistics as the training set. Now we talk about statistics here in a broader context, because you have to understand at the end of the day, whether any image, for that matter, because as long as it's a digital image, any image can actually be identified and recreated. So this is one aspect that you have to understand early on. So generative model is pitted against an adversary or a discriminative model that learns to determine whether a sample is from a model distribution or that from a data distribution. So there are actually many types of generative networks, but so far most of them actually just use likelihood ratios and all that, but so far it's the generative adversarial networks that has more more into creating a more perfect version of the image or the model that you want to copy. So again, showing you that there are many types of generative adversarial networks, but in terms of generative adversarial networks, we liken it to having, or analogous to, counterfeiters and a cop. So as you can see here, there's a team of counterfeiters trying to produce fake currency and use it without detection, while the discriminative model is analogous to that of the police in trying to detect the counterfeit currency. So with this game ongoing, you'll be able to finally create a much perfect, because of this going on, you'll be able to create a much perfect, or a currency, a fake currency that will seem so much better than the real currency. In fact, that's one of the problems that we have right now, because the creation of currency is so good that they can, in Hollywood, for example, they make fake currencies, right, whenever they do shoots. So creating all those fake currencies can actually be more, more and more becoming what is reality. It looks more and more real, or at least real to the naked eye. So there's a thing also, the game theory, which is important to understand whenever you talk about GANS. So the learning problem is a zero-sum game between two following players. So the first one is the generator, which aims to generate real-like samples from a random noise input. So initially, every image that the generator will create will be randomized. So it's as I mentioned, it's a little weird. And then you have the discriminator G, which is trying to distinguish the generator's generated samples from the real training data. So the discriminator is the one which tells the generator, for example, that this is wrong, or this is not a real image of what you're trying to create. So eventually the generator will come up with much more images, and then eventually it will mimic, or it will have an image that is similar or much more better than that of the discriminator is telling. So this is just a computational example of how generative adversarial networks look like. So the goal of GANS is actually to train the generative network that produces sample from a data distribution by transforming the vectors of noise. And looking now at the training signal for G, it is provided by a discriminator network that is trained to distinguish samples from the generator distribution from that of a real data. So the discriminator in this sense is the one that is being trained, or that's the one that you are giving the real training data that you have. So the generator network in turn is then trained to fool the discriminator into accepting its outputs as being real. So the next thing that's going to happen with all this game ongoing, there's what we call a Nash Equilibrium. So a Nash Equilibrium actually happens when, or it is a point where each player, the discriminator and the generator and the discriminator, cannot reduce the cost without changing the other player's parameters. So One useful approach for the theory of GANS is to show that divergence between the training distribution and the model distribution obtains its minimum value at equilibrium. However, there are recent studies right now showing that maybe, GANS may not have a Nash equilibrium. So this is another aspect of of research that is currently being studied. So this is a good example. So let's try this one. So Zoo actually developed an interactive application called Eigen, or Interactive Generative Adversarial Networks. As you can see, based on this example, the user only has scribbled a few green lines. So this is the few green lines. And based on this few green lines, this is based on the few green lines, the machine was able to create all these images. It was able to create a mountain with a grassy field using a simple black triangle. So a black triangle suddenly turning into a mountain based on a simple generative adversarial networks. And also, this can be applied in so many aspects, especially if you are an artist, for example. So a simple image, and you can already create a much more detailed version of the image that you are trying to portray or to create. Another example is this by Isola in 2016. So she created like a concept what they call image-to-image translation, which encompassing many kinds of transformation of an image. So it converts a satellite photo into a map, converting it to a sketch into a photorealistic image. So this is the input, and this is the ground truth. So this is practically what you're doing. This is practically the discriminator, and this is the generator. And then eventually, with all these things, with all this two interacting together, the generator and the discriminator, you're able to create an output which is more or less similar, and actually it looks much better than what the discriminator is trying to tell. So it's even much better if you look at it. So because many of these conversion processes have multiple correct outputs, it is also necessary to use generative models to train the model correctly. So the next question that we will be asking here is that in terms of the ground truth, in terms of the discriminator, we have to, and I think this is one of the weakness of this model, is that it's only able to create images based on what you've shown, based on what the generator is trying to creating, or what the generator is showing, what the discriminator is showing with the generator. So this is an example again of images taken from ImageNet dataset. So these are the different images, and then using your generator and discriminator, it is able to come up with this image. It's not perfect, but at least with this, you're able to actually see that it more or less looks, like an animal, right? But it's still not, it's still not as perfect as you want an image to be. But at least with this here, you can learn recognizable features such as the fur, the eyes, the noses. But these features are not correctly combined to form an animal in a real or realistic anatomical structure. But given only a few training sets, for example, based on these images, just imagine how from these images, the machine or the framework was able to create something like this in a few epochs, for that matter. So this is fascinating if you think about it. And then in 2015, Lotter again and his colleagues provided an excellent illustration on the importance of being able to model a multimodal data. And in this example, you can actually see that the model is trained to predict the next frame in a video sequence. So the image on the left shows an example of the actual frame of the video, which would be, this is the ideal perfect image. And this is what happens when the model is trained using the mean squared error between the actual text. And but if you use the adversarial model, actually you can see the ear is much more clear here, as it's much more similar to that of the ground truth, or the image that you're trying to copy. So comparing MSE with adversarial in this sense has much more, it's able to create a much more realistic model of the image that you're trying to show, or a much more detailed image than compared with other generative or other models for that matter. So this is another example of stack GANs wherein it is able to achieve higher output diversity other than GAN-based text-to-image model. So from Zhang, actually, this is a small blue bird with a short pointy beak and brown on its wings. So if you can see, it's able to create a much clearer, or at least an image that is much similar to reality. So in conclusion, again, this is relative by new. It has been new, at least for some of us, but it has been in existence since 2014, and it truly revolutionized how we see images. And generative adversarial networks have an extensive application in creating imagery, especially in astronomical images. For enthusiasts, for example, if you can get a small image and then use a discriminator, you'll be able to create a much clearer images. And in healthcare as well, so it can be used to generate sharper and clearer anatomical images, such as when you have glaucomatous images. So it has it has a good application in ophthalmology, wherein you are able to detect glaucomatous images early on based on a simple image of the eye, for example. And in research, we can help to generate protein images, which can be helpful in cancer treatment. And the adverse side of this is really it's used in deepfakes, which can be used in producing, again, fake images. So be very careful of the people that you are going to associate or talk or engage with, even in Facebook, even in LinkedIn, because sometimes those images are not actually real. So again, we go back now to the question of who is real. Who do you think among these images that you see is real? Is it A or B? So the image here is actually B. The real one here is A. So the image that you see here is real. This is real A, but the B image is not real. So X, this is not real. Okay? And then the next one is who is real? What do you think? Give me a few seconds. So it's actually both of them. So both of these images are not real. You can see all this in the link down below. So make sure to read my links down below, because I will also show you where I got those images from. And you can actually go to the site to see who among these images that you have is not real. Okay. So this another one, this third set. So who do you think is real? Is it A or B? So the real one here is B. A is not a real image. So this is just a generated image. This is actually, the fourth one is actually quite fascinating. Who do you think is real in these two images? No, actually, both of them are not real. So these are all manufactured images. So image A is not real, and image B is also not real. It's quite fascinating, right? The B actually image looks real, but it's just an image generated by your generative adversarial networks. And then the last one. So who do you think is real? So the real one is actually A. B is a generated image. So yeah, that ends our session. And if you like, please subscribe to this channel, and then tell your friends about this channel. And if you have, if they haven't subscribed yet, and if you have subscribed, please make sure to click that like button. And if you like it, and make some comments down below, and read what's my references as well, so that you'll be able to understand clearly how generative adversarial networks actually work, and how it can be applied, specifically in healthcare. So with that, I bid you adieu, and I hope you have a good day. Be safe and take care of yourself all the time. Okay, guys and gals, and everyone in between. All right, so bye.